This is the Mastery Study Guide video for topics 18, 19, and 20. So again, we're still sticking with our radical expressions, radical equations, rational exponents. So with number 18, we have a square root and an equation. So what we want to do is isolate the square root. In this case, there's nothing to the outside of the square root. We'll talk more about that in example 2. But 4x plus 1 is what's being under the square root. If there was anything else outside of that square root, we would have to get rid of that first. Because there's not, the opposite of a square root is squaring, so we're going to square both sides. The square cancels out the square root, so on the left we have 4x plus 1, and 3 to the second power is 9. Easy two-step equation from here. You guys know what to do. Subtract 1 from both sides, and divide both sides by 4, so we get a solution of x is equal to 2. With these, it's always a good idea to go back and check your answers to make sure none of them are extraneous. Example 2. When we isolate what is underneath the radical, it's, I went a little too fast. Let's go back a little bit. Nope. So because the negative 2 is not underneath the cube root, we have to divide both sides by negative 2. We end up with the cube root of x minus 6 equals negative 3. Now we have isolated what's underneath the root, so we are undoing it by taking both sides to the power of the index. So in this case, it's a cube root, so we need to cube both sides. The cube cancels out the cube root, so on the left we get just x minus 6, and then negative 3 to the third power. We have to be careful. It's negative 3 times negative 3 times negative 3, so we actually get negative 27. Isolate x by adding 6 to both sides. Solution, negative 21. Number 19, solve basic exponential functions. This is all about changing the base. So we want to get the same base so we can set the exponents equal. So if I look at my bases for example 1, I have 2 and 16. Because 2 is a prime number, I can't change it. However, I can rewrite 16 that has a base 2 because I know 2 to the 4th power is 16. So my left side's not going to change, but I'm going to rewrite 16 as 2 to the 4th power. Again, I have to put that in parentheses and still keep that x minus 4. It's still 16 to the x plus 4 power. So power of a power rule says that I multiply. So I have 2x plus 2, that stays the same. And I'm actually going to have to distribute that 4 since I'm multiplying. It's 4 times the binomial x plus 4, so I get 4x plus 16. Now that I have the same base, I can drop the bases and set the exponents equal to each other. From here, just get the variables on the same side and move the numbers to the same side. We end up with negative 14 is equal to 3x, so our solution, negative 14 over 3. Example number 2, we have 9 to the x plus 1 power, 27 to the x minus 3. I can't take 9 to any power to get 27, so this one we're actually going to have to change both of our bases to 3. So I accidentally pressed play a little too quick, but I changed 9 to 3 to the second power, so I need to change 27 to 3 to the third power. Again, keeping both of those exponents on the outside of the parentheses. So it still is 9 to the x plus 1 and 27 to the x minus 3, but we rewrote them so they have the same base. Just like we did in example 1, power to a power rule says multiply, but we do have to distribute. So 3 to the 2x plus 2, and then 3 to the 3x minus 9. Now that we have both of the same bases, drop them and solve the remaining equation. So when we subtract, we get 11 equals x, and that's our final answer. All right, we're looking at number 20, and this is one that didn't go that great on the last chapter test. But in reality, all we have to do for these is change them to their radical equivalents, and they give us pretty easy numbers. So 8 to the 1/3 is the same as the cube root of 8. Subtraction sign. 27 to the 2/3, 3 is the index number, and we're taking it to the second power, so it's the cube root of 27 squared. And then we have to remember at the very end to square that. So the cube root of 8, we know is 2. The cube root of 27 is 3, and 3 to the second power is 9. So I replace the cube root of 8 with 2, and the cube root of 27 squared with 9. Then I just need to follow order of operations. 2 minus 9 is negative 7, and negative 7 squared is positive 49. Example 2 is a power to a power rule. Don't get intimidated by the square root sign, you're just multiplying them. So we've got 5 to the root 2 times negative root 2. When we multiply, What's inside stays inside. So 2 times 2 gets multiplied. We get 5 to the negative square root of 4 power. But we know the square root of 4 is 2. So we have 5 to the negative second power. And this is going back to, I believe, either topic 16 or 17, where a negative exponent does not make a number negative, it just bumps it to the denominator and makes it positive. And then we know 5 squared is 25, so final answer of 1 over 25. That will conclude this video. Thank you for listening.